It's a treasure box.
How do we open it?
I think we have to do these problems.
Let's go inside and figure them out.
Okay.
Let's talk about the least squares regression line.
It is called the least squares regression line because it minimizes the variance or the sum of the squares of the errors.
For example, in the graph we have here, the LSRL is the line that makes the overall distance of each point from the line as small as possible.
It's basically the line of best fit for each of the data points given.
The least squares regression line is always in the form of y hat equals a plus bx. The a is the y-intercept and the b is the slope.
Here, a is the y-intercept, and we find this by substituting y hat in this equation for the mean of y, and x for x bar, which is the mean of x, and then just solve for the a, and you end up with a equals y bar minus bx bar.
We can find b by multiplying the correlation of the two variables r times the standard deviation of y over the standard deviation of x.
The least squares regression line is also used to predict a particular y value from a given x value. In most cases, the LSRL does not perfectly pass through each data point as shown here. Therefore, we calculate the error between the predicted value and the actual value by subtracting our predicted y from our observed y. So our predicted y value here is 2, and our actual y value is 1. So therefore, the error is 2 minus 1, which is 1.
Those errors are actually called residuals. You can find it by the equation y minus y hat, which is observed minus predicted.
If you use an x value that is too far outside of this range, you are extrapolating and your prediction will not be accurate.
The least squares regression line can also be found using your graphing calculator. When you go and enter your values in list 1, that represents your x values. In list 2, those represent your y values.
Then press stat, then calc, then 8. The values of a, b, and r should then be visible.
Now, for examples. Our first example. An ecologist examined the relationship between the number of new birds, y, and the percent of returning birds, x, for 13 sparrowhawk colonies. The data is shown below. Now, part A says, enter the data into your calculator and make a scatter plot.